You hear about AI all the time, right? Artificial intelligence. It's in our phones, it's in our cars, it feels like it's everywhere. But if someone asked you to, define it, it's actually kind of tough, isn't it? It's one of those words that everybody uses, but the precise meaning can be a little fuzzy. So let's try to fix that. Let's cut through all the hype and figure out what we're really talking about when we talk about AI. So yeah, let's just get right to it. What is artificial intelligence? And here's the kicker. There's no easy answer. Seriously, this isn't some new debate either. The experts, the very people who have been building this stuff for years, have been arguing about the definition for decades. So if you're a little fuzzy on it, hey, you're in good company. And this whole debate is actually part of a way longer story. The hunt for an artificial mind. That didn't just pop up with the first computer. No way. We're talking thousands of years ago. Think about it. All the way back in 350 BC, you had Aristotle trying to figure out the basic rules for how we think, for rational thought. That's the real starting point. And that ancient quest is what eventually led to the name artificial intelligence in 1956, and, well, to the huge world-changing field we have today. Okay, so to really wrap our heads around AI, the best way in is to look at how the experts themselves have tried to tackle the question. Over the years, they've come up with 4 main ways to think about it, and these all fit neatly into a kind of grid, based on 2 big ideas. So here's that grid. It's actually a pretty brilliant way to sort things out. It all boils down to 2 key questions. First, are we trying to copy how something thinks on the inside, or do we only care about what it does on the outside? And second, are we measuring it against us, messy, imperfect humans, or are we shooting for some kind of perfect, logical, ideal intelligence? And when you cross those 2 questions, boom, you get 4 different ways to approach AI. Let's start in that bottom left box, acting humanly. This one's pretty straightforward, and this quote nails it. The idea is simple, let's just make computers do stuff that, right now, people are better at. That's it. This is exactly where the famous Turing test comes from, right? The whole point is, can you build a machine that acts so much like a person that you can't tell the difference? Okay, now thinking humanly is a whole different ballgame. Here, it's not good enough to just get the right answer. The AI has to get to that answer the same way a human would. This is all about cognitive modeling, trying to get inside the black box of the human brain and simulate all the messy, weird, sometimes illogical ways we actually think. It's about the journey, not just the destination. All right, next up is thinking rationally. You might call this the laws of thought approach. And yeah, this goes straight back to our friend Aristotle. The goal here is pure, cold, hard logic. We're talking about systems built on things like mathematical proofs. The idea is to create an engine of perfect reasoning, something that is provably 100% correct every single time. And that brings us to the last box, acting rationally. This is a huge one. This is all about building what we call rational agents. And the key thing to get here is this approach doesn't care how the AI thinks. It could think like a person, it could think in pure logic, it could think in some alien way we can't even imagine. It doesn't matter. The only thing that matters is this. Does it do the right thing to achieve its goals? It's all about the final action, the result. And that last one, acting rationally, well, that's pretty much become the main idea behind most modern AI research. And it's for a really practical reason. Think about it. Trying to prove a machine thinks just like a human, that's almost impossible. But measuring whether a machine achieves a goal, that's something you can actually do. This focus on performance, on results, is why this idea of the intelligent agent has become the go-to framework for building stuff that actually works in the real world. So what the heck is an intelligent agent? The textbook definition sounds a little dry. It's something that perceives its environment with sensors and acts on it with actuators. But let's make that real. A self-driving car, right? Its sensors are the cameras, the radar, the lasers. Its actuators are the steering wheel, the gas pedal, the brakes. The agent is the brain, the software that takes in all that sensor info and decides how to use the actuators. It connects seeing to doing. And it's basically just a constant loop. See, decide, act. See, decide, act. Over and over again. The agent sees what's happening, figures out the best thing to do, and does it. Then it looks again at the new situation, and the whole cycle starts over. It sounds so simple, but that little loop is powerful enough to describe almost anything that makes decisions, from the thermostat on your wall to, us. Okay, so we're building these intelligent agents, but what goes inside that decide part of the loop? What kind of smarts does an agent actually need to make good decisions?
Well, this is where AI gets really big and pulls in ideas from all over the place.
Yeah, to build a really capable agent, you need a whole toolkit. You need logic, and you need probability to deal with a world that's messy and uncertain. You need perception so it can make sense of what its sensors are telling it. You need reasoning and learning to connect the dots and get smarter over time. And you need to be able to plan and then actually do something. And hey, if you wrap all that up in a physical body, well, that's what robotics is all about.
So we've come a long way, right? From ancient Greek philosophers all the way to this modern idea of an intelligent agent. But that's all a bit theoretical. What does this stuff actually look like when you put it to the test? Let's check out a real-world example that is just mind-blowing.
Get this, back in 2005, in tech time, that's like the Stone Age, a car with nobody inside drove itself all the way across the Mojave Desert. And I don't mean a quick spin around a parking lot. No, no. We're talking 132 miles of rough, unpredictable, unpaved desert roads. Just think about that. This car, its name was Stanley, is the perfect example of an intelligent agent in action. It used its sensors, cameras, lasers, all that, to perceive the crazy desert terrain. It used its software brain to reason about the best way to go, and then it acted using the steering, brakes, and gas. It followed that perceive, decide, act loop perfectly, and it ended up winning the DARPA Grand Challenge. It was a huge, huge moment for AI. So, from Aristotle's simple rules of logic to a car that can literally find its own way across a desert, it's clear this quest to build intelligence has come an incredibly long way. But as these AI agents get smarter and more capable, and as they become a bigger part of our everyday lives, a new question starts to pop up, a really important one. As these things get more and more powerful, what do we want them to do? What should their goals be? And maybe most importantly, who gets to decide?